Hey guys, nice to meet with you guys today. And yeah, I'm the only one in the room, so I can take my mask off. We're gonna go. I didn't get to finish this lesson, and you have until Sunday. So this is kind of like tomorrow's, but I want you to. Some of you will have time today to work on it, so I'll go ahead and have it posted for today. And again, you have a digital copy. If you prefer working on paper copies, then I can get those for you. You just give me a call or a text at 512-637-7411. It's posted at several places, and I will arrange for you to have paper copies if you prefer to work those. Now, not everything will be on paper. There still will be some other assignments that you can only access through the computer, but at least you can, if you prefer working on paper, that's an option. So the section that we didn't get to in class and that is slated for Friday's objective is to how to evaluate functions. So that's what we're going to do is do evaluate functions. I'm going to switch the camera over, and that'll take just a few seconds. And this is starting on page 3 of that lesson 1, part 1. The top of the page has the vertical line test. So we went through that where we just kind of yes, this one's a no, that's a no. So this is part 4 where it says function notation. So function notation is when you see this f of x. So what it stands for is function of x. So we translate that, we usually say f of x. So we say like the letters. But it stands for function of x. So this is a function of x, which is just a fancy way to say y equals. So it's another way to say y equals. So this would be the same thing as y equals 2x plus 3. This is the input, the number that goes into the function, and this is the number that comes out. In my mind, it makes more sense to, I don't know, and what comes out is f of x or y. So we put some number into the function here, and then we're going to get out a number. And hope if you've done any of our math courses, you should be familiar with something that says y equals, and you'll still see y equals a lot, but you will also see this. Now they generally use the letter F, but they might use the letter G, H, F, G, H. They start that place in the alphabet. So this function is F, and here it is, f of x is 2x plus 3, and I want to find the value. I want to find if this is the x, then what's the output? If I put this is the number in parentheses is the input. So this is the input, or the x. This is also called the independent variable, independent. So let me I think I can show you better on a bigger thing. So the function starts out as f of x. And that function, f of x, is 2x plus 3. Yeah, now I'm getting situated. So what I want to do is I want to find out what this value is. What if if I put in -1 for x? So what I'm going to do, here's my function rule. This is called the function rule, is I'm going to take x, the letter, out, and what goes in its place is the value. So this goes into wherever you see the x marks the spot. So the x came out and this number came in. Now it's just a matter of doing the calculation. So Now 2x really means 2 times the value of x. When you see a number and a letter stuck together, that indicates multiplication. Now in order to show the multiplication with this, I need the parentheses. So the parentheses are very crucial, especially if this number has a negative with it. So what I'm going to take the x out and bring this in with the parentheses. Now what this is here, I'm going to multiply that and then add 3. Negative 2 plus 3 is 1. So this function, when x is 1, you can't see that. When the input is negative 1, the output is 1. This is the x, and this is the y. I could translate this. This is function notation, but I could use this. I could translate this to an ordered pair or a coordinate pair, and this is the point negative 1, 1. So I could write it in function notation. I could write it as an ordered pair, or sometimes they call it a coordinate pair. And guess what? I could also translate that to a point. I'd go over to negative 1 and up 1, and I could plot that point. Start at the origin and go to the left and then up. So these 3 things are just different ways to write or represent the same information. So that's this value. Now this is an older copy of the worksheet, so you have something that I think looks nicer, and you have 2 questions for each of these. So I'm just going to be working the one, but I know you guys have 2 questions here and 2 questions here. So I worked this example on the board, the big screen. Boop, boop, boop. But I'm going to work this one on the paper. So it says f of x equals 5x minus 1, and then this is a semicolon, and this is asking the question. So I'm looking for what is the value of this function when x is 10. So this function rule says multiply by 5, then subtract 1. So I'm going to take this 10 and bring it into where I see the x. And notice I bring the parentheses with it. So instead of 5x, it's 5 times 10. So 5 times 10 is 50. Then I subtract 1. And my final answer is 49, which means the value of this function when x is 10 is 49. Now what I want to do is translate that, because oftentimes they will ask you to take this and translate it to a coordinate pair. So the coordinate pair, or also called the ordered pair, do you know it? Have you said it in your head? Let's see if you're right. Yep. So you have another one, and so you work that one, and then on your own, and if you're not sure about something, just give me a quick snap a picture, send a text, and I can give you a thumbs up or thumbs down real quick. So this one here, here's the function rule, and then this is asking the question. So the rule is 2 plus x squared, but I'm looking for what is the value when x is 3 or negative 3. Now I really want to be very cautious on this one and close. 2 plus x squared. So 2 plus x squared. Now I didn't write the parentheses, and because I didn't write the parentheses, this will give you the wrong answer. If you put this in the calculator is only going to square what it's next to. So this one, and this is still the wrong answer. I'm showing you the wrong way to do it. This is the wrong way to do it. this becomes a -9 because this is only squaring the 3. If I put the parentheses, now this becomes a +9, and that is the correct answer, or the correct next step. The correct answer is 11. Now there's a place where you could just say that's the answer, but I really want to get you familiar with the notation, which is what I've been writing. So the notation says that f of -3 is 11, or the value of this function when x is -3 is 11. If I put in a -3, I get out an 11. This number depends on this number. This is the dependent amount, and this is the independent. And I'm going to be using these words a little bit later. Now can you translate that to a coordinate pair or an ordered pair? Yep, I know some of you have it correct in your head, which is -311. This is the number in the parentheses is the x, and what it's equal to is the y. Now notice on these two, when they have the number in the parentheses, they're giving you the x and they're asking for the y. But they can also ask this question in a different way. And let me see if I can find one like that. Not yet. Let me do one real quick. So there is another kind of question that's very similar. Now, you're not doing any of those today. I'm going to just hold off. But what they can do sometimes is that I can give you the 49 and you tell me the 10. I can give you the 11 and you tell me -3. So we can reverse this process. What it looks like, and let's say I don't know what x is. I don't know that this is a 10, but I know that if I calculate it out, I get a 49. So if you had to work this backwards, you could work this backwards. What I would just do is solve this equation. Now so I don't know the x, that's what I need. There. It needs a little shadow. There's just too much glare in this room. Sorry. So 5x minus 1 is 49. So if I need to find the x, I'm going to look at this and decide what to get rid of. I need to get rid of the 5 and the 1. And you always start with the weakest operation, which in this case is that negative, that -1. So I would go +1, +1. And I would still have the 5x over here. This would cancel out, and this 49 would become a 50. Then I'm trying to get to the x, and they're stuck together. So when they're stuck together, that means multiply, and the inverse of that would be divide. So then I would divide by 5, divide by 5. Beep. X equals 10. So I found the 10, but the 10 is the x. So right now, I'm going to only give you the x, and then you calculate the y. Later on, I'll give you the y value, the output number, and you'll reverse the process by doing algebraic equation solving to find the x. So we'll get to this a little later. That's a little preview. But let's look at a couple more problems. And again, this page might look slightly different than your page because I have reformatted this since I printed this copy, but it's pretty much the same. And so this says f of 3, but notice that I've given you two different functions. This is an f function, and this function is called g. So because this one says f, I'm going to stick right here. So f says 3 is, the function rule is multiply by 3 and subtract 4, or 3x minus 4. Now sometimes what I like to do is go to the x then, and then put parentheses. That's where I'm going to put my number. So 3, and the number that's going to go in right there is another 3. So this 3 is this one. This 3 came from the parentheses. And then subtract 4. 3 times 3 is 9. 9 minus 4. This answer is 5. This is what comes out. Is this the, now answer this in your mind, or say it out loud, I don't care. Is this 5 the X or the Y? It's the Y, yes. And if I translated that to a coordinate pair, it would be the 0.35. This is the X, and this is the Y. But let's say, look at this one. Now this one says G of 2. So because this says G, I'm going to skip this one and go to this one. So G of X says X squared plus 1. So G of X, X squared plus 1. I'm going to always write the function rule. I'm going to find the X and put parentheses, then put that in there. So 2 squared plus 1. So the X gets replaced. 2 squared plus 1. 2 squared is 4 plus 1. And that answer is also 5. F of 2, what is F of 2? 5. That could also be the 0.25. Now here's where you may want to pause the video and work this section. Starting with number 18, this one is more complicated. So if you want to just pause and kind of practice, this is level 1, this is basic level, where you put the numbers in and you decide is it F or G, and then whatever letter they use, then you go to that function. If it says F, you go to this one. If it says G, you go to that one. And when you feel confident, we'll look at these more complicated ones. So let me look at these more complicated ones. Now this has 2 parts. There's something there's 2 letters. So what I'm going to do is I'm going to really separate this out for right now. I'm going to find F of 4 and figure that out. And then I'm going to find G of 1 and figure that out. So I'm going to figure out this number and figure out this number. And at the very end, I'll subtract them. So F of 4, so I go up to F, that is 3x minus 4. That's the function rule. I find the letter X, put some parentheses around it, and now I'm going to put the 4 in there. 3, 4 minus 4, 12 minus 4. This one is 8. Didn't give myself much room there, did I? So 3 times 4, and then 12 minus 4 is 8. Now that's just this part. So this is worth an 8. Now G of 1, so it says G, so I'm going to go to the other function rule, which says x squared plus 1. Square it, then add 1. So I'm going to start with the number 1. Well, I'm going to put the parentheses around the x and then rewrite it with the 1 in there. 1 squared. Now, how much is 1 squared? Now remember that what this means is this is 1 times 1. So 1 times 1 is 1, and then you add 1, and you get 2. So G of 1 is 2. So if F of the value of the 4 is 8, and G of 1 is 2, now what I'm going to do is subtract them. 8 minus 2 is 6. So this is the final answer, but it has different parts. Now, it really is a bad glare here. You'll notice this one And this one, they have like other stuff around it. So what we want to do is work from the inside out. So I'm going to find out what this is separately. G of -1. G is x squared plus 1. That's the function rule. And now I want to put this in. Put the parentheses, put your number in. If you do not put the parentheses for this negative number, you will get it wrong. If you put it in the calculator without the parentheses, it will give you the wrong answer. So make sure you carry that negative with it, with the parentheses. It needs to all be there, and that the parentheses help package it. It's like a package, and to get it packaged together, you have to use that parentheses. Now when you go -1 times -1, you end up with, is it a positive or a negative? Positive 1 plus 1. This one is 2. So the 2 goes back in here. So this part is 2. So I have 3 with a 2 plus 2. Here's the 3. And then instead of G of -1, this came out to be 2. 3 times 2 is 6. 6 plus 2 is 8. That's the final answer. So you're going to work from the inside out. Now these are nested, and again, think about working from the inside out. And again, if you've got an idea, feel free to pause the video, try it on your own, and then check to see if you're getting what I'm getting. That'd be a great way to kind of test your understanding. So G of 1, I already figured that out. So this part, the inside part, I'm just going to use this answer because I've did it already. So what I'm looking for, if this inside part, which is the same thing I have here, is 2, then I need to find f of 2. Now for G, I use the G rule. Now for f, I'm going to go back to the f rule, which is 3x minus 4. Three times 2 minus 4, 6 minus 4. Final answer. I'm going to close the video right now. As you can see with these fly-ins that I've got a meeting coming up, and you have the information. This one is going to work the same way as that one. It's just follow, again, do the inside first and then the outside. Good luck with that. And I am going to say it again, call, text if you have questions. Text me photos of what you're working on. I'd love to be able to check your work as you go. You know how it feels good to know if you're getting it right or wrong.